Hello everyone, this is Group 79 and our project is SMS Spam detection using machine learning. Our team consists of Tushar Agrawal, Puneet Jaswani and Division. We are using myself, Tushar Agrawal. So we are using the SMS Spam collection dataset and we begin by loading it and displaying a few sample rows to understand its structure. So first we imported the necessary libraries that are important for creating this project. So next we imported our dataset using the pandas. Next, what we did is we cleaned the data set by dropping the unnecessary columns and renaming the remaining ones to result in SMS. We also check for the null values and remove duplicates, reducing our data set slightly to ensure data quality. Next, let's move on to the exploratory data analysis, which is the EDA. So first, what I did is the distribution of the labels into spam versus ham distribution. So, as you can see, first we examine the class distribution. As the pie chart shows, the dataset is imbalanced. Around 87% as we can see are the ham messages and 13% are the spam. So this imbalance could affect our model's performance. So let's move on to next the average length of SMS for spam and ham. So we calculated and we compared the average length of spam versus ham messages. So here we found that spam messages are long on average, about 137 characters versus 70 for ham. This makes sense as spam messages often try to convey more information. So let's move on to the average word count of SMS for spam and ham. Here, as we look at the word count, spam message contains about 27 words on average, while the ham messages we can see is around 17. This again reinforces the verbosity of the spam text. Next, we move on to the average sentence of SMS for spam and ham. So as we can see that the spam messages also tend to have more sentences. As we can look there, the average sentence is about 3 for the spam and the average sentence length of about ham is about 1.7. So this suggests that the spammers try to break messages into persuasive chunks. Next, we go on to the relationship between the length and the spam. We check the correlation between the message length and the spam likelihood. The correlation coefficient is around 0.38, indicating that the longer messages are slightly more likely to be spam. Next, we move on to the features correlation. So here we explore the relationship between the length, word count and the sentence count. Length and word count are highly correlated and there's moderate correlation with sentence count. Next we move on to the data preprocessing. Now we preprocess the text. We convert to lowercase, tokenize the text, remove punctuation and stop words and apply stemming. Finally, we rejoin the clean words to form a transformed SMS column. Next, we did the word cloud analysis. So to visualize the most common words and we generate word clouds, spam messages often contain words like call, free and text indicating promotional or we can say scam content. In contrast, ham messages use casual and conversational words like okay, you and come. So next we move on to the label encoding. So we encode the result column converting spam and ham into binary values. Spam becomes 1, ham becomes 0. So next we trained our model. So we vectorized the transformed SMS using TF-IDF to convert text into numerical format, selecting the top 3000 features. We then split our data into training and testing the sets. First model is support vector classifier. It gives strong results with high precision and accuracy. Second model is a random forest classifier, so which also performs well but is slightly less precise than SVC. Third is our naive Bayes classifier. We test naive Bayes, which is fast and accurate, though precision is a bit lower compared to SVC. Next, we did the model comparison, comparing all models. SVC performs the best overall in terms of both accuracy and precision. Therefore, we select SVC as a final model. In conclusion, I would like to say that our model successfully detects spam SMS with high accuracy. This project demonstrates the power of EDA, preprocessing and machine learning in real-world text classification. So thank you so much for watching my video. Thank you.